In this lesson, we are going to learn how to perform the composition of two functions. Consider the function f of x equals 2x minus 5. We just have a linear function, and we've learned early on that we can evaluate this function by simply plugging in 2 where there's an x. So this would be 4 minus 5, which is negative 1. We can plug in negative values, like f of negative 1 would be 2 times negative 1 minus 5 would be negative 2 minus 5 is negative 7. We can plug in other letters. We can plug in Greek letters. We could plug in the letter delta. 2 times delta minus 5 is just 2 times delta minus 5. We can even plug in other functions. Like we could plug in another linear equation like x plus 3, which would just mean everywhere there's an x, we plug in x plus 3. Well, what would we do here? Well, we wouldn't be able to figure out a numeric value, but we could at least distribute and get 2x plus 6 minus 5, which is 2x plus 1. This process of plugging in a function into another function is known as the composition of two functions. So this notation right here, this open circle, this is read as f composed with g of x, or f of g of x, which means we're plugging g of x into f of x. Let's demonstrate this with some examples. So on the screen, f of x is quadratic and g of x is linear. And we are told, first of all, to compose f composed with g of x, which is equivalent to f of g of x, which means we're plugging in g of x, this function here, into f of x. So everywhere there's an x, I'm going to plug in x minus 4. So what I end up doing here is I need to distribute x minus 4 to x minus 4, which gives me x squared minus 4x is minus 8x plus 16 plus this 1 here on the end for a final new function of x squared minus 8x plus 17. Now, I'm going to actually go down and do number 3 next, which says find f of g of 2, which is really the same as finding f of g of, I'm just switching colors here to help your eyes, hopefully, meaning we're going to plug 2 into g of x, and then that answer into f of x. So if I plug 2 into g of x, that's going to be 2 minus 4, just show you in 2 steps here, which is negative 2, and then I'm going to do f of negative 2, so I'm going to plug negative 2 into f of x, which would be negative 2 squared plus 1, which would be 5. So f of g of 2 is equal to 5. Now, I also want to point out that we could have plugged it into our new function. We've composed them, and we have what f of g of x is. So f of g of 2 is also equal to plugging 2 into that function, so it'd be 2 squared minus 8 times 2 plus 17, and you would just evaluate this would be 4 minus 16 plus 17, which also gives me 5. Now I want to illustrate that function composition is not commutative. Switching the order is going to make a difference here. So in the next function, or next example, I've been asked to find g of f of x, or g composed with f of x. Right? So this time we are plugging everywhere there is an x, so I have x minus 4 for g of x. I'm going to plug in f of x, which was x squared plus 1. And I just combine my like terms, and this gives me x squared minus 3. So good notation here would be g of f of x is equal to x squared minus 3. And now I'm going to jump down to 4, says find g composed with f of 3, which means I'm plugging 3 into my new function. So this would be 3 squared minus 3, which would be 6. Okay, alternatively, you could have shown this by doing g of f of 3, which means you plug 3 into f of x first, which would be 3 up here would be 3 squared plus 1 would be 10, which would then be equal to be doing g of 10, and g of x is x minus 4, so 10 minus 4 is 6. So I get the same answer both ways. Okay, so now we're going to talk about the domain of composed functions. So I want you to start with the domain of the inside function. And then after composing, you're going to find the domain of the new function. And most importantly, you're going to find the union of these two. So let's find the domain using these examples. So you're given two functions, and again, we're told to compose f of g of x and g of f of x, and then we are plugging in 1 for each of these. And considering the domain, I'm going to look at the domain of my inside function here, which g of x is going to be all values greater than or equal to 0. So my domain for this will be 0 to infinity. Okay. All right, so if I'm plugging in g of x into f of x, this will be the square root of x plus 1. And I'm not going to be able to really clean that up anymore, so let's think about my new domain. Do I have any new restrictions to state? No, the domain of this is also going to be 0 to infinity. So my new domain is exactly the same as before. It is the union of my new and that inside function. Okay, so next we are asked to find f of g of 1, and that is within my domain. So I'm going to plug 1 into my new function, and that's going to give me root 1 plus 1. Well, root 1 is just 1, plus 1 is 2. Okay, now I'm going to switch directions, and again, we're going to see that this is not commutative. I'm going to get a different function when I go. So we're going to find g of f of x, and I'm going to consider the domain of f of x. So back here at the original, this is linear, so its domain would be all real numbers or negative infinity to positive infinity. All right, so I'm going to plug in f of x into g of x, which is going to produce the square root of x plus 1. And since I can't take the even root of a negative value, I need to say that x plus 1 must be greater than or equal to 0. So x must be greater than or equal to negative 1. So the domain of all real numbers, my inside function, and my new restrictions right here would just be x is greater than or equal to negative 1. So my domain is negative 1 to infinity. And next I'm going to actually calculate g of f of 1. Right, which means I'm plugging in 1. Oops, didn't mean to slide the writing around, which would give me the square root of 2, which is irrational, so I'm just going to leave that as root 2. Okay, so one final example here. Let's just start by looking at our domain of both. So I've got a quadratic here for f of x, so that's going to be all real numbers. G of x can't divide by 0, so I've got to say that the denominator x plus 1 can't be 0, so therefore x cannot be negative 1. So my domain would be negative infinity to negative 1 union negative 1 to infinity for that one. Okay, now let's actually do our compositions and see if we need to find any new restrictions. So we're going to begin by doing f of g of x, which means I'm taking g of x and plugging it into this. So I'm going to have 1 over x plus 1 squared, which to algebraically clean this up really means that I have it there twice. So if I just write it side by side, this will be a little bit easier to see. So in the numerator, 1 squared is 1, and x plus 1 times x plus 1 gives me x squared plus, I get a trinomial, I have 1x plus 1x would be 2x plus 1. So my inside domain was negative infinity to negative 1, and I need to consider if I have anything new. Well, the denominator here, again, anything that would cause the denominator to become 0, I have to restrict. Well, the only thing that's going to cause this would be negative 1 in both cases, because there's 2 factors in the denominator. So my domain here is still negative infinity to negative 1 union negative 1 to infinity for my composed function. All right, so here we go, and let's do f of g of 1. So if I put 1 into everywhere there's an x, that gives me 1 squared is 1 plus 2 plus 1 on the bottom, which is 1/4. All right, let's switch directions. So we're asked to go the other direction. And I left my 2 domains of the original on the screen for you to see. So now I'm going to do g composed with f of x, also written as g of f of x. And what am I doing? I'm plugging in x squared now everywhere that there is, an x. So 1 over x squared plus 1, that's not going to clean up anymore. So my original function, or my inside function, had all real numbers. Now I do have a fraction, so I got to consider, is there anything that's going to break the domain, anything that will cause my denominator to become 0. Well, if I plug in a negative 1 here, because I'm squaring it, it's going to be positive 1, so I'm not going to have any new restrictions. So my domain here is all real numbers. You could also write that negative infinity to positive infinity. All right, now finally you're asked to do g of f of 1. So I'm just going to plug that into my composed function. 1 squared plus 1 is going to give me 1/2.